video is about functions, including domain and range. So if we had a graph like this, the first question we want to know, is it a function? So visually on a graph, you can identify whether the graph is a function or not based on the vertical line test. So if I were to draw a vertical line anywhere on this graph, and I find a spot where it hits the graph 2 times, like it would touch this pen here, up here, and down here, it is not a function. Another way of explaining it is when x is -2, it has a point at +4, and when x is -2, it has a point at -4. When x is -1, it has a point at about 3.5, and it has a point at down here also. For it to be a function, every x can only have one y, but when x is -2, it has 2 different y values. Therefore, it is not a function. Okay, then this is a graph of g of x. So instead of x, x has been replaced with 1. So this is saying, what is the value of the function when x is 1? So if we go to the x-axis and we go to 1, it has 2 values. It has a value here at 1, 2. So when x is 1, y is 2. And it has a value at 1, -2. So when x is 1, it had 2 different y values. Another reason why it's not a function. Okay, then we're asked to find the domain. Domain represents all the possible x values. So for example, if x was -10, it has a point, actually 2 on the graph. When x is -5, it has a point, actually 2 on the graph. But when x is +5, there is no graph over here. There is nothing, the graph is all going on this side. So x will never be these numbers here on the right. So we need to state domain is what are all the possible x values. So if we look at the x-axis, it's going to go infinitely here on the left side, but it never passes on the x-axis. It will never pass in the positive direction too. So x such that x is anything less than or equal to 2. The whole graph is on the left side. Those are where all the numbers are less than 2. Now we can also write that in interval notation. It's going infinitely to the left side, so -infinity, and it goes all the way here to 2. And 2 is included, so we put a bracket around it. Okay, then we're asked to find the range. So the range are all the possible y values. So now we're going to take a look at the y-axis. So if we look at the y-axis here, okay, there is a point. If I go to 1 here on the y-axis, there's a point on the graph that will have a y value of 1. If we look here on the y-axis, this function is going to keep going and going and going and getting wider and wider and wider. So no matter what, if we look at the positive y-axis, it's going to go infinitely up in the positive direction. And if we look in the negative direction of the y-axis, this is going to keep going and going and going and going. So no matter what, every point on the y-axis is going to have a spot on the graph. So the range for this is y such that y is a real number. For our interval notation, if we look here, we always go least to greatest, so we start with the left side over here. And here it's going infinitely in the negative direction. And then this y-axis here, the graph is going infinitely to the positive direction. And remember, we always put parentheses around infinity. Okay, let's take a look at another example here. Okay, we have a parabola. It asks whether it's a function. If I were to draw a vertical line, it only touches the graph once, right here. If I draw a vertical line here, it only touches once. If I draw one here, it only touches once. No matter what, there's no spot on the graph where it will intersect, a vertical line will intersect twice. So it is a function. That means every x value has one y value. Okay, then we're asked to find, instead of x, what is the value of this function when x is, so here's the x-axis, 0. So if we go to 0, when x is 0, the y value was negative 3. Then we're asked to find the domain. So domain are all the x values. So if I start on the left side, the left over here, and I look at this graph keeps getting wider and wider, and it's going to keep going and going and getting wider. So if we look at the arrow of the graph here, it's going infinitely to the left side. And then if we look here at the positive direction for x, it is going infinitely in the direction of the positive side of the x-axis. So the domain here is x such that x is a real number. Then for interval notation, it's going infinitely in the negative side, and it's going infinitely on the right side. So x could be any number here, and x can be any number here. So for example, if I go to positive 10, there will eventually be a point on the graph at 10. All these x values will be used. Okay, then the range are all the possible y values. So if I start where the numbers are less, there is no graph down here. The lowest number being used on the y-axis is negative 3 right here. Everything on the graph is above negative 3. All these points, all these solutions on this parabola, on this graph here, is all the points are above negative 3. So for example, if I picked this point right here, that point is at 3, 6. Notice the y value is above negative 3. All these points have y values above 3. So y such that y is greater, above, or equal to negative 3. The whole graph is above negative 3. Then as interval notation, we're going from negative 3, and then it's going infinitely up in the positive y direction. Okay, let's go ahead and take a look at our next example here. So this one should be one that we are very familiar with because this is a linear function. It makes a straight line. So we definitely know that this one is a function. No matter what, wherever I draw a vertical line, it is only going to intersect the graph. If I draw a line there, it only touches once. There's no spot that if you draw a perfect vertical line, it will touch the graph twice. Every x has one y. Every x has one y. Every x will have one y if we extended this. When I go to 5, it will have one y value. Okay, then instead of x, it asks us, what is the value of this function when x is 1? So here's 1 on the x-axis, and that point is 1, 4. So the value when x is 1, the value of the function is 4. Okay, now we're asked to find domain. So domain are all the x values. So no matter where I go on the negative side of the x-axis, no matter what, if I go to -5, it will eventually, the graph, if I extend the graph, it will eventually, there will be a point. No matter where you go on the negative side of the x-axis, there will be a point on the graph. Now, if we look at the positive x direction here, no matter what, there will be a point on the graph. So our domain is x such that x is any real number. So our interval notation for that would be it's going infinitely in the negative direction, and the graph is going infinitely in the positive direction. Now for the range, all the possible y values. So if we look at our y-axis here, and we start with the lower numbers, so we're going to start down here, no matter what, if I go to -10 on the y-axis, there's a point. If I go to -5, there will be a point. There will be a point. No matter what, all the values on the y-axis in the negative direction are being used. And if we look at the y-axis, the positive y numbers, no matter what, there's going to be a point on the graph. So y such that y is any real number. And as our interval notation, it's going infinitely in the negative direction, and it's going infinitely in the positive direction. Okay, let's go ahead and take a look at one last example here. Okay, it asks if it's a function. This is definitely not a function because if I draw a vertical line right here, it touches twice. So this is no. Then it wants to know what is the value of the function when instead of x, we find the value when x is -3. It has two values. It has a value of 2 and -6. And when x is 0, it also has two values, 3 and -7. Okay, then the domain are all the possible x values. So if I look at the x-axis, it stops right here at 5. It never goes further from 5. And on the negative side of the x-axis, it doesn't go past -5. All the x values, all the points to make this circle are all in between -5 and 5. So x is in between -5 and 5. So the reason why we're putting the equal to is because this circle has no, it's not dashed, it has no open circles, open dots on the circle, everything is solid. Okay, then our interval notation would be from -5 to +5. Then our range. So our range are all the y values. So y never will go past 3, and y will never, the y values for this graph will never pass -7. So all the points on this graph are in between the y values of -7. So all the y values are in between -7 and +3. So for our interval notation, it would look like this. let's actually we'll do one last one here. If we look at this graph. Okay, so our domain are all our x values. So the graph will never go to the left over here. It stops right here at 3. But it keeps going and going further and further. Keeps going and going and going on the right side. So our domain are all the x values that are getting greater and greater and greater. So all of the x values are greater than or equal to 3. So in interval notation, that would look like we go left to right, so it's at 3, and then it's going out to infinity. Okay. Then our range are the y values. So the graph does not stop here. It keeps going and going and going up in the positive direction, and then down here it keeps going and going and going. It's going up infinitely and down infinitely. So y such that y is any real number. And then for interval notation, negative infinity to infinity. It could be any y value. And then it asks, is it a function? That would be no, because if I draw a vertical line and I find that it touches twice, even though it only touches once here, if I find one spot that it touches twice, it is no, because when x is this value right here, it has two different y values. Okay, and then the last part says, instead of x, what is the value of the function when x is 3? 1, 2, 3. So when x is 3, the value of this function is 0. When x is 7, the value of the function is 2 and negative 2.